Hi, I'm Jean-Pierre Talbot, SE for SonicWall in Canada, and today we are doing site-to-site VPN. Actually, this is the first of 3 videos because I always film the content before filming the intro and I realized I had way too much stuff to do a single video, so I've cut it into 3 videos. So the first one, this video, will do site-to-site VPN between those 2 firewalls. So we'll first start where both have a fixed IP on their internet line, then we'll switch. That one have a dynamic IP where the head office remain with a fixed IP address. Then we'll do policies, right? I'll show you briefly security because by default everything is wide open. That's great, everything works. Viruses too. So I'll show you how to turn off the policy that allows everything and how to create policies to only allow what you want. And I'll finish by messing up my VPN and showing you how to do troubleshooting, because it's easy to fix something you've broke on your own, but it's more of a challenge to fix something you don't know why it doesn't work, right? If you're trying to build a VPN, it doesn't build, you don't know why, well, it's kind of nice to be able to go in the logs to find out what's going on. So what I'll do, I'll change, I believe encryption by default I've used is AES 128, and I'll change this guy to triple des, which of course will kill my VPN, and I'll show you how to find in the log what you've done wrong. So that's the video we'll do today. The next video, I will do a VPN with a third-party firewall, and I've picked a red box. So that will be the second video I will do. And I'll put the link in the description box down below. And the third video will be adding another remote office firewall. So that will be head office to remote office firewall. And I will also add SSL VPN client connecting to the head office. And I want to make sure that everybody can talk to each other, right? So those two, they do VPN to the head office, but they don't have a VPN between each other. So I want to be able to say this guy can talk to this guy through the VPN of the head office. So it will go from remote site 1 to the head office and back in the VPN to remote site B. And the SSL VPN user will connect to this firewall, but will also be able to use the actual VPN between those two to be able to talk to all 3 sites. So that will be the third video. And well, I think that's enough content. So if that's the type of content you like, make sure you hit the subscribe button so you don't miss out on upcoming videos. So first, let's start without this guy, build a VPN between those two, fix IP, dynamic IP, do security, and then troubleshooting. So I'll first start by showing you the setup I have over there. So we'll start with the head office firewall. So we have a NSA 3700 here, and for now it only has internet access connected to X0 here, just like our TZ470 here has a internet access, which is just going to a switch where we do have a internet feed. And for now, my laptop here with the yellow cable is connected to the TZ here. So on the LAN here for the TZ, it's 192.168.10. something. And the LAN here where there's nothing yet, on X0 on the head office firewall, the LAN is 192.168.100.0. So 100 and .10 here. So goal is to do VPN between head office and a remote site and to get traffic going through. So we'll first start with fixed IPs on both, then we'll move on having dynamic IP here and a fixed IP there. So let's first start with our TZ470. So firewall is factory default. The only thing that is not factory default is the fact that it is licensed, so it's registered. And I changed the IP on the LAN and the WAN to reflect the setup I have here. So as you can see here, the TZ LAN is 192.168.10 and the LAN is a fixed IP. For now, it's 142.39.19.200. So first we will configure our TZ because that's the one we're connected to. So I'll go into Network, IPsec VPN, Rule, and Setting. As you can see, there are none. So what we do, we click on the Add button up here. So first thing I want to touch here is policy type. So what type of VPN we want to do. So today we'll do simple basic site-to-site VPN. But there is one here, as you can see, tunnel interface. So I've already done a video on tunnel interface because I really like it. So rule of thumb, if you have one internet provider at each site and you only have one subnet that you want to be able to reach another subnet on the other side, that is site-to-site VPN, the one here, the simple one. If you do have multiple internet lines at each location, or at least one of the two locations with multiple internet lines, or you do have multiple remote location, or you also have a disaster recovery, you know, everything that is more complex than one ISP on each side and one subnet on each side to connect. Every time it's more than this, I strongly advise people to go with tunnel interface. Yes, it's more complicated, but to create, because, you know, with site to site, everything is here. You go through those 4 tabs, your VPN is done working, that's it. With tunnel interface, well, you need to go through those 4 tabs, then you need to create a virtual interface, then you need to create a route, and then you need to create access rule. So yes, it's more complicated, but it gives you way more. For instance, if you have multiple internet lines, that means you can create multiple VPN going to one location. And then you can add on top SD-WAN, where you would say, you know what, for VoIP, because VoIP doesn't care about fast, it cares about quick. Because, you know, they're quick and fast is not the same thing, right? If you bring this to cars, Tesla are quick, but they're not fast. Bugatti is fast. They're not that quick. Well, they're quicker than all my cars, but Tesla is quicker to go to zero from 0 to 100 kilometers, where Bugatti, it can go to 400 kilometers an hour, where Tesla cannot. So Tesla is quick, Bugatti is fast. So for VoIP, it's the same thing. VoIP doesn't really care about fast, it cares about quick. How many milliseconds it takes back and forth to get there. Because if you have a huge delay, like you have a lot of bandwidth, but it's long to get the data there and back, then your VoIP traffic will be kind of weird, right? When you have that slight delay with people and you have 2 people talking over each other because, well, it was silence for a second. So SD-WAN will be able to identify VoIP, and you'll be able to configure it to say, well, take the VPN that has the lowest latency and lowest jitter, because that's what VoIP care about. So that if you want to do those type of thing, that's a tunnel interface. And I've done a video on how to set up tunnel interface, and I've done a video on how to set up SD-WAN on top of 2 VPNs. And I actually have VoIP going through, and I play with latency jitter, and I increase it with a WAN emulators, and you see traffic bouncing from one VPN to another because the latency is better and things like this. So if you are going through those more advanced thing, that's a tunnel interface. So stop here, don't continue with site-to-site VPN. Go in the description box down below and click on the tunnel interface VPN. So for now, simple site-to-site VPN, one ISP at both ends, one subnet that we want to connect both LAN of each location. Super simple, that's what we're doing today. So we pick site-to-site, we give it a name, whatever name you want. Here, it does not need to match on the other firewall. So here I'm on the TZ firewall, so I'll say VPN to head office. Here I need to put the external IP of the other firewall. And remember, here I'm doing a VPN with fixed IP addresses on both ends. So the fixed IP address of the other firewall is 142.39.19.100. So that's the external IP address of the head office firewall, the 3700 in my case. As you can see, we are on the TZ here. Shared secret, I'll put password. So, you know, do something better, right? Password is not the best password ever. So, local ID. So that's something when you do have 2 fixed IP, well, 1 fixed IP address at both ends, I personally advise to leave it to your IPv4 address. So here you put your external IP address and you put the external IP address of the other firewall. So that's it. Give it a name, put the IP address of the other firewall, a pre-share key, your local external IP address, and the external IP address of the other firewall. Network. Here we are talking internal subnet. Here, right, that was external IPs. Now we're doing internal subnets. So I want to connect X0 on my firewall to the X0 of the other firewall. So simple here, drop down here, pick X0 subnet, and the remote network, as you can see, we don't have anything. So we need to create an address object for the LAN, the X0 subnet of the other firewall, the head office in that case. So create new address object. It's X0 HO for head office. It is into the VPN zone because that subnet we will create is in the VPN. It's a network and it's 192.168.100.0.10.0 and it's a /24. So again, X0 of the head office of the other side of my VPN. It's 192.168.100. That's the LAN interface of the other firewall, and that's a subnet that is accessible through VPN. So hit on save, close. So I'm doing a VPN. I want my X0 subnet, my local subnet here in that case for that firewall is 192.168.10 to be able to connect to X0HO that I just created, which is 192.168.100. Proposal, that's what I like about doing VPN between two SonicWall. Well, if you put the exact same firmware, you're pretty much guaranteed that the default value here will be the same. So very important, every single settings here must perfectly match for your VPN to build, because you can build VPN with other firewall if you want. You will need to hunt down those settings on the other firewall. But here, because we do VPN between two SonicWall, well, the default will be the same on both. So we just leave it as is. Next, there are three settings I've enable keep alive. You need one of the two firewall to have enable keep alive on. So because both firewall have fixed IP addresses, both can do the keep alive. In the event where you have, which we'll do in a few minutes, one firewall with a dynamic IP address and one firewall with a fixed IP address, the one having the dynamic IP address will be the one to do the keep alive. So we'll cover that when we get there. So for now, I will just pick the first firewall to be the one doing the keep alive. Second topic I want to talk here is suppress automatic access rule creation for VPN policy. By default, the firewall will create two policies, allow everything from the VPN and allow everything to the VPN. So all ports, all protocol, all IP, all subnet wide open. Well, all subnet you've selected here, right? X0 to the other X0. So everything will be wide open. I'm not a fan of it. But for now, we'll leave it as is. After that, we will go in access rule and create the exact access rule we want, right? So for now, just for testing purposes, I recommend leaving this off. Test that your VPN works. When it works, come back here, enable this. So then there will be no access rule. So you will feel your VPN is down. Well, the VPN is not down. The VPN is still up and running, but no access rule allow any traffic at all. So nothing works kind of, and you feel it's down, but it's not. It's just, there's no access rule. So you need to create access rules to allow traffic, which we'll do later. Another one I like is to enable this. So that allows you to manage the firewall through the VPN. So you could, because remember here, this firewall is 192.168.10.1. The other firewall is 100.1. So once my VPN is running, I will be able to open a new tab and say open the web browser for 192.168.100.1, and it will bring me the management interface of the other firewall. So I'll be able to manage the firewall through my VPN. So I find it really handy. So turn that on. Okay, and that's pretty much it. So one firewall to have the keep alive. We'll play with this one later. Turn on management so you can manage your firewall through the VPN, which is kind of nice, and hit save. So once our VPN will be up somewhere here, we will have a little green dot, but we don't have it yet because we haven't configured the other firewall. So I'll just disconnect myself from the X0 of the TZ470 and connect myself in the X0 of the NSA 3700. Okay. So I am now disconnected from the TZ. I just unplugged from X0, connected to X0 on the 3700. So here we need to do the exact same thing, pretty much. So I'll just show you here. Network, system, interface. So see here, LAN is 100, 192.168.100, and my external IP is 142.39.19.100, and the other one is 200. So let's go again, sorry, network, IPsec, rule and settings. Same thing, click on add. It's a site-to-site that we're doing. Here, the name again does not need to match, so I'll call it VPN to remote location. Here, I need to put the IP address of the other firewall. (300) 142.39.19.200. That's the IP of, again, the external IP of the other firewall. Shared secret, it has to match, of course. So here I did put password, but please do better. And here, local IC ID, remember my external IP is 100 and the other firewall is 200. So of course, on the other firewall, if you recall, it was the exact opposite because the remote external IP of the other firewall is its local IP, right? So pretty much done here. Network, exact same story. So here we pick X0 subnet right here. And here the same thing, we need to create a address object for the X0 network. Oops, I pick group, sorry. Here pick network address object. So we call it X0 remote office. It is in the VPN. It's a network, and the LAN of the other firewall was 192.168.10.0 255.255.255.0. It's a /24, and it okay. Close. So here my X0 going to X0 remote, which is 192.168.10. Proposal, again, because it's two SonicWall with the same firmware, they are the same by default, so they have to perfectly match. So if we don't touch it, well, it's gonna be the same on both, so we're good. Here, because I've turned on Keep Alive on the other firewall, I don't turn it on here. I will turn on management as well. And later on, we'll play with disabling policies. So hit unsave. And if you did everything right, you should have a green button, a green dot showing up here. Then you can hit refresh and see we got a little cool green dot. So our VPN is working. So now remember, I am behind my firewall, my NSA 3700. So now I should be able to manage the other firewall, right? So if I go here, hit refresh, that's a good sign. And I'm connected on the other firewall through the VPN. And as you can see, I do have my little green dot as well. So one thing you might do that you might be wondering, why is it not working? If you're trying to ping, it does not ping. So you'll be like, well, why is it not working? I can get to the management interface of the firewall. So obviously it works. Why is ping not working? Let me show you that. So as you can see, I am here on X0 and I'm trying to ping the other firewall, the X0 of the other firewall, which is here. But I have nothing connected here. So how do you expect to ping an interface that is down? So what I'll do, I'll just move myself here. I'll move myself back at the remote location, and at the head office, I'll bring what you will most likely have at any head office. That's called a switch. now it will probably work way better. I'm connected now behind the remote office firewall, and I'll be able to ping the external, the LAN IP of the firewall because now the interface is up. So I wanted to show you that because usually when you build a VPN, you might do it on a bench like this and you'll be like, well, why is it not working? It's because you have nothing connected. So let's test again. Of course, now I am at the head office firewall. So I'll just do a IP config. So you see I am on 192.168.10. So again, behind the small TZ, and let's ping 100. And now because the interface is up, of course it answers ping, right? And obviously I will be able to come here and log into the internal interface of the remote firewall and be able to manage it as well and kick myself out. Kick my other self out. So we have our VPN working. I am currently behind the remote office firewall. So the other part I wanted to show you before we move on to doing a VPN with a dynamic IP address, I want to show you about network security, right? Because right now we do have a VPN that allows absolutely everything, right? Let's go see that. Policy from here, from let's say VPN to LAN. This policy here, see, we do have the last policy here, X0 remote, so the subnet of the remote network, can connect to the entire subnet of the head office on service any. So anything goes in. The same way the other way around. If we do from LAN to VPN, it's the same thing. Locally, 192.168.100, so everything at the head office can connect on any IP at the remote site on any service, all ports, all protocol, wide open. So ransomware, keylogger, everything is free to go. So you get the point. If you have something going south at the remote location and you allow absolutely everything, odds are quite good that a ransomware will make its way from the remote office to the head office and kill everything. So if you do create the policies that you need, then you'll make sure that, well, you give yourself way more chances that a ransomware will not make its way from the remote location to the head office. So I will go on my TZ because I am connected right now behind the TZ. So on that firewall, I will remove the policy, the checkbox that automatically create all access rule, right? So network, IPsec VPN rule where we were, edit the VPN, advance, and suppress automatic access rule creation. So I'll save this and see if I try to ping. It does not ping anymore. But see, my VPN is still up, but I don't ping. So that's just because all policies have been deleted. So what I'll do, I'll create the policies that I want. Oh, and just to show you here again, I'll close this tab and reopen it, but I won't be able to manage that firewall either, right? Timeout, because there is no policy allowing anything. So let's go in policy, access rule. I will pick from LAN to VPN, and I will create access rules to allow only one thing. Let's say I'll just allow management of the firewall and not ping, right? So I'll click on add, create a access rule. We'll call it firewall management in VPN. It will be from LAN, from any IP, let's say, going to the VPN, and I will be very specific here. Let's say I will create an address object, new address object. We'll call it HO firewall. It is an object that is in the VPN. It's a host. And the IP I want to be able to connect is 192.168.100.1. And I want only HTTPS, right? So I'm creating a policy saying anyone in the LAN behind the TZ470 can go in the VPN on a host that is 192.168.100.1, which is the internal IP of the other firewall, and only on management. Click on add. So if we try to ping, it will not work because I only allowed HTTPS, not ping. We'll just let time to show 1 lost ping, 2 ping lost, enough. And let's try to manage the firewall. See, it doesn't work because I'm not on HTTPS. Remember, I only open HTTPS and here it's trying HTTP. So let's do HTTPS and it works. One thing to keep in mind, you do not need to match the policy creation thing. See here that we're on the head office firewall. Well, that thing here is not checked. So the in that specific case, the head office firewall allow everything in and out. It's only the head office firewall that has a policy to only say, well, I only allow this. So you do not need to match policies on both ends. And personally, I would usually do the opposite. I would have the head office firewall that would take care of all access rules to say who can talk to what and so forth. And the remote site, I wouldn't care. Just like, yeah, sure, let everything go. If you want, all the control for the VPN are done at the head office because all the remote office do VPN to the head office. So let's have one central point to control everything. So here, the TZ only accept its LAN to manage the remote firewall, the head office firewall. And that firewall doesn't, the head office firewall just allows everything. It doesn't care. So traffic, if the head office firewall, someone at the head office would try to manage the remote firewall, well, that firewall will let it go through the VPN because it's like, yeah, I have policy to allow everything inside out. I don't care. Then the traffic would go in the VPN. The traffic would then arrive at the other end of the VPN, which is this firewall, and it would be policy going from VPN to LAN. And there would be nothing to allow remote desktop or management of the firewall or things of that nature because we haven't created any policies. And now something else I want to show you. Let's do a little bit of VPN troubleshooting. So we will unpurposely screw up our VPN. So I'll go here, edit my VPN, proposal instead of AES 128, I'm gonna pick triple des. So it will not match on both ends because the head office firewall is still on AES 128 and the remote location wants to do triple des, so they won't be in an agreement. They will get into a fight and the VPN will not build. Or actually it is built, so now it's gonna drop. So then I want to show you troubleshooting that logs what logs will show you to help you fix your VPN. So see, my little dot is gone. So let's see if that still works. And of course, it does not, right? I cannot connect VPN. So what you can do here, one important point is VPN is somehow like a client and server thing. So here I am behind that firewall. Yes, I'm behind the TZ firewall. So, and I'm trying to get the VPN going by sending traffic. And also the keep alive is here. So everything that will force that firewall to be the one initiating the firewall, because I'm the one trying to send traffic. It's that TZ that also has the keep alive. So the TZ is the one that is going to try to build the VPN. And it's again like a client and server thing. So if you are the user to try to log in to a system, well, don't expect to receive an error message that will be very verbal and tell you exactly why it doesn't work, right? It will tell you fail, like bad username and or password. You won't get much detail, but on the server, you could see exactly what was wrong, right? So if we go here in logs on the TZ, there won't be much that we will see. Monitor, logs, system log. So, you know, we have a payload error, right? It doesn't say much. Receive notification error payload. So the other firewall just says, well, sorry, no go. I don't want to build a VPN with you. So let's go see the head office firewall. Who's the one that received the VPN request? Who's the one that will be kind of like the VPN server thing? Because whoever trying to build the VPN is kind of the client, and whoever received the request is the one that actually is the server type of thing. So I'm on X0 of the NSA firewall, which is the server I refer to. So that one will give me more explanation as to why the VPN didn't build. So monitor, log, system log. See, IKE v2, IKE proposal does not match. That's much more verbal than the other one was. So IKE v2 proposal mismatch instead of just error. So we know that it's on the IKE portion. Does not match. VPN policy, VPN to remote location, encryption algorithm mismatch. So we know much more. Local is AES 128 and peer, the other guy, triple DES. So you got it in plain sight here. Why did your VPN did not build? Because you had a IKE proposal mismatch and the VPN policy was locally on AES 128, but the peer, the other guy, trying to connect with triple DES, right? Let's see this. So remember that local, so this firewall, AES 128, and the peer is trying triple DES. So let's go see what we have. Network, IKE, and here proposal is for encryption is AES 128, which is exactly what we had, right? And if you don't remember, just rewind the video. We changed from AES 128 to triple DES. So here I could just go here and select triple DES and hit save, and my VPN will build. Refresh. There we go. My little dot is there. So again, VPN, see it as a client server thing. Whatever firewall trying to build the VPN, that firewall that trying to build the VPN is the client. It's calling the other guy, hey, I want to build a VPN with you. So if the proposal don't match, the client will just receive a no. But the server knows exactly what was wrong. So then don't look for a reason on the firewall that initiate the VPN. Look at logs on the firewall that received the VPN request. That one will show you exactly what was wrong, which is what I showed you here. So the remote location was the one trying to initiate the VPN. So I will have the reason why the VPN doesn't build on the head office firewall in my case. Okay, now switching to a VPN with a dynamic IP address. So right now I'm behind the remote office. So remote office generally, most of the time, will have a dynamic IP address. So we'll change the external IP address of this firewall so that it is a dynamic one, right? Here, one here is set as static. So let's change that for DHCP and hit OK. So again, we're on the TZ, the remote office firewall, and let's hit refresh, no renew, and I got an IP 142.39.19.59. So that's the IP of the day, let's say, right? Of course, it's DHCP, so it will change. So we need to update our VPN because remember we did a VPN with a fixed IP address on both ends. So if we go see VPN, my VPN is down now, right? I don't have that little green dot anymore. So we'll need to change the VPN config, and of course it has to be changed on both sides. So click edit on the VPN. So here, to try to keep things simple, I often compare doing a VPN with one end having a dynamic IP address to mom and son that wants to have a call, but mom is always home, always have the same phone number, and she's carrying that phone number for decades, right? So mom has a fixed phone number. But you, the son, your son, her son, you're traveling around the world. You're always in a different country. Sometimes you're on an airplane, sometimes in a boat, in a train, at the hotel. So maybe sometimes you'll use a public phone to call your mom, and sometimes you'll use the hotel phone to call your mom. Sometimes there is a phone in the train, so you use the phone train. So mom will wait and expect a call from any random phone number, thinking that, well, it might be my son calling. And of course, when you the son, you are in Italy at the hotel and you decide, hey, it's been a while, I'll call my mom. Of course, you pick whatever phone you have laying around, the one in your room, or a public phone, the one at the bar, whatever it is, and you dial the fixed phone number of your mom, the phone number she's been having forever. And the discussion will start, hey mom, it's your son, how are you? And then you could have a pre-shared key, a password, which you don't really have, but you could say, hey, that the code for our discussion is potato123, right? We don't do that. That's where IT in real life get different. So that's kind of what we're gonna do with a VPN, where one end has a fixed IP and the other end has a dynamic IP. One end has the fixed phone number and has to wait for any inbound request coming from any IP, right? And then a discussion will start. Hey, I am this firewall. I want to build a VPN with this firewall. And here is our pre-shared key. So here, that's a phone number. Here I'm on the remote firewall, right? The one that has a dynamic IP that will call the fixed IP. So that firewall knows that this is the head office. That's the fixed IP. So we're still calling that fixed IP to build the VPN. Where things will change, it's here. The pre-shared key remains, but here we cannot, local ID, that IP will change, right? You're not gonna go in the firewall every day and change that IP to bring back the tunnel. That's not gonna work. So instead of using IPv4 as a mechanism to say, hello, I am this firewall, I want to build a VPN with you, we're gonna switch to firewall identifier, and you can pretty much put anything you want. So here, that's the remote office firewall, so it will call itself RO firewall. Firewall with 2 L's, not 3. And the peer, the head office firewall, we'll call it HO firewall. So that's you, the son, right? Your mom's son having a dynamic IP, dynamic phone number, and you want to call your mom. So what's going to happen is you, the one that moves around, that have a different IP, you will always call the fixed IP, the head office firewall. And you will say, hello, I am RO firewall. I would like to build a VPN with HO firewall, and here is my pre-share key and all those encryption here. Then the VPN will build, of course, if we've set it up on the other side as well. So the other side will wait for any IP to call, and as long as they say, hello, I'm RO firewall, we'll want to build a VPN with HO firewall, here is the password and all the proposal of stuff here, then the VPN will build, right? So VPN to head office, all we do is change this and keep note, it's case sensitive, right? RO and HO are all in capital, and firewall is lowercase. And here I saw we're still in triple des, so we'll change it back to what the default is. So, don't poke around with this. That was just to do a demo that I did to show you how to troubleshoot your VPN. So I'll just put it back to what it is by default. So that's it for what we have to do on our remote firewall. Hit save. Then I'll connect myself in X0 of the head office firewall and do the same change. And we're back here, and as you can see, obviously our VPN is down. So let's edit the VPN on the head office firewall. Remember here, IP address, well, that we don't know what IP address the remote office firewall, because it will change every day. So 0000. So we're just saying, just wait for anyone to call whatever IP they have, right? Pre-share key remains the same. And here, we cannot do identification with IP address because they will change. So we need to do the exact same thing we've done on the other firewall. So here, local IC ID, that's the head office firewall. So it's HO firewall. And here it was RO firewall, right? The exact same thing, but reversed. So here the firewall, this one will say, well, I'm gonna wait for anyone to try to build a VPN connection with me. Of course, it has to be password as the pre-shared key. It has to call itself RO firewall, wanting to build a VPN with HO firewall, and all the proposal here need to match, right? And as you can see here, enable keep alive is disabled because there is no way the firewall can keep the VPN alive and build the VPN when it has no clue what IP address the other firewall will have. So you need to ensure that this enable keep alive is on the firewall having the dynamic IP address, in that case the TZ. So here, that's pretty much it. We just put 000 here, pre-share key, a name that will match that you flip around on the other firewall, of course, because local and peer will be the opposite on the other firewall, and hit save. And of course, we're on the NSA 3700. So that one cannot try to get the VPN to work, right? I can try to ping the other side, which is 10.1. But that firewall is like, yeah, I would really like to build a VPN, but I don't know what is the IP of the other guy. So it has to be the other firewall that will build the VPN. So let's connect behind that firewall and try to get a ping going. And actually, the interface was down. I was not connected to it. So even if the firewall built the VPN, X0 was down on the TZ because I had nothing connect to it. So next, let's go on the TZ interface. And see, now the VPN is up. So, and see that thing refresh right away, and I'm able to connect. So that's how you do a VPN when you have one end having a dynamic IP address. In the event where you have both sites with a dynamic IP address, yes, you could play within DNS services, but keep in mind that they might not refresh that quick. Some say, oh, it's super reliable. No, it's not. In my experience, it is not. It works when you test, you change the IP, works right away, but 6 months down the road, well, it took 30 minutes to update, so you were down for 30 minutes. So just do the math, right? How much does it cost for the head office or one of the two offices to have a fixed IP address? That's probably, I don't know, 20, 30 bucks more per month, so 300 a year roughly. And how much it costs for employees to not work for an hour until you fix it? Well, probably more than 300, right? If you have 10 employees, $300 will fly by super fast. So do yourself a favor, have one end having a fixed IP address. Best have both ends have a fixed IP, but always look which firewall, in which way my traffic is going, right? If you're into retail business, you have one head office and many stores, and all those stores need data from the head office, right? They will try to get inventory or process transaction or whatever it is. So usually in retail, stores need stuff from the head office. So in that case, head office has a fixed IP address, and all the remote stores can have a dynamic IP because they're the one initiating the VPN. They're the one that need data from the head office. So that will work perfect as you saw it here. So that concludes that first video of 3 on site-to-site VPN. The other 2 is a video where I do a site-to-site VPN with a third-party firewall. In that case, it will be a WatchGuard. And the other video that most of you will want to see is where I cover everything about routing through VPN, meaning I will add a second remote office, so I'll have the head office that do a VPN to both remote offices, but I will allow both remote offices to talk to each other through the head office VPN. and I will add a SSL VPN client in the mix that connects to the head office firewall, but also leverage the site-to-site VPN to be able to reach to the other two remote offices. So that's the other video that will air eventually soon. So I would strongly advise that you subscribe to my channel if you want to see those videos and don't miss out when I release them. So thanks for watching and see you in the next one.